Alright guys, next portion is just kind of this free response section. These are questions I came up with. These are not College Board questions, so keep that in mind. The multiple choice was College Board based questions. The free response questions here are things that I wrote just to kind of give you an idea of some free responses that could show up. Again, most of the time these types of questions are not in the free response section in any way, shape, or form. But it's still good practice, and it's a good way to make sure you actually fully understand what's going on. Okay, so the first part is draw a metallic solid on a particulate level. Particulate level just means down to the atomic level, and answer the following questions. Include the structure and sea of electrons in your picture. So remember, metals, first off, are individual atoms. They have that closet packing system, which basically means they're all kind of close together, and honestly, if you stacked them in rows, it probably wouldn't hurt anything. Okay, but that's kind of how I draw it. Sea of electrons is a lot harder to draw. All I kind of do is just draw a cloud around it, something along those lines, and that shows my sea of electrons. Okay, from there, explain how the metal is able to conduct electricity with what you drew in your picture. So what is it about metals that allows them to be able to conduct electricity? It's that sea of electrons, and the fact that those electrons are covalently, non-directionally covalently, whatever you want to say, bonded, which means the electrons are free-flowing within the structure, which is what allows for electricity to be able to exist, is the electron's ability to be able to flow. Okay? And then what would your metal look like if it became an interstitial alloy? Okay, and sometimes with interstitial it's easier to draw it more on a stacked versus that closet packing, because then you have a little bit more spaces to work with. So interstitial would be the atom you're putting in here is smaller and therefore is filling in the holes left by the metal. Okay? And it doesn't matter how many you put in there. I just put a few just to kind of show what it would look like in a simple scale. Okay, from here, sodium fluoride, an ionic solid on a particulate level, and answer the following questions. Includes the size of the atoms or the ions and the charges in your picture. So first off, we're looking at sodium fluoride on our periodic table. Sodium is positive, and it's also going to be much larger due to the fact that it is further down on the periodic table, and then fluorine is going to be smaller and negative. Okay, or what you could also do is basically say, okay, this guy is the positive sodium atom, and then the small white one, open one if you will, is the negative fluorine ion. Either way, you could either draw it like this with a positive, negative, or you could have some type of key off to the side. Either way works. It's kind of up to you. Okay, and then with ionic compounds, remember we have the alternating charges, so positive, negative, etc. However you want to do it. Again, whether you are doing a key where you have the solid circles and open circles, or whether you're drawing your positive negatives. Either way, it works for me. Okay? And then draw your ionic compound showing cleavage and briefly explain what cleavage is. Okay, and you saw that in one of the multiple choices, so again, this is why I have it here, is just to basically make sure you think about what it is so that you can answer the multiple choice questions appropriately. Okay, remember basically what cleavage is when you have the two charges next to each other that are going to repel and break off. Okay, so this is just a continuation of the last video. Hopefully we are feeling okay with solids. Solids really aren't too bad, but definitely require a little bit of thinking and problem solving skills. So that's it for this. Hopefully these help. And let's move on to the next set of material.